service in a private subnet and restrict external access to the database. You can limit access to your database by allowing access only to specific trusted protected systems using security rules. You can use a NAT gateway to access resources in public network, like you can access My Oracle support to download the patches. You can use a service gateway to connect to other public services in Oracle Cloud Infrastructure, like the object storage. You must ensure delete database, DB system delete time privileges. These are only granted to the trusted cloud account administrators or the selective data owners. Else, this can be misused to delete a database with some malicious intent. To wrap up this lesson, these were just a few pointers that you can take into account while provisioning your database in Oracle Cloud Infrastructure. This will keep your database safe and protected from any kind of threats. You can take a look into the public document as well to deepen your understanding of these concepts. Hope this should be helpful in a small way. Thanks for watching. Welcome everyone. In this video and the subsequent ones, we will expand our understanding on the different self-securing capabilities of an Oracle Autonomous Database. Oracle Autonomous Database provides various self-securing capabilities, which includes secure and controlled access, automated security patching, data encryption, and strong separation of duties, etc. So that keeps your data in Oracle Autonomous Database entirely safe to operate and manage. Let's check how Oracle Autonomous Database enforces controlled access to your database environment and protects your database from any internal or external threats. Access to the host system is locked. That is, there is no access to the database host server or the file system, thus reducing the attack surface of Autonomous Database. The provisioning automation of Autonomous Database ensures each provisioning happens from a security hardened gold image, and you are not required to access the database system, which rules out any scope of malware installation in the host system or could open the room for external attacks. No SysDB access is granted to any user in Autonomous Database. Instead, every Autonomous Database consists of a username admin, and it is assigned limited privileges, those that are necessary to perform majority of the database admin activities. There is a strong separation of duty enforced between the service administrator and the service consumer by using Oracle Database. It guarantees that no Autonomous Database service administrator can abuse your database. They neither can view nor modify any data stored in Autonomous Database. The network access boundaries for your Autonomous Database in Oracle Cloud Infrastructure is set in the database provisioning step itself. You can limit who are the target audience that are allowed to access the data. You have the option to even place your critical database in a private subnet and have configured network security group and security list to ensure access from specific endpoints. It uses TLS 1.2 network security standard to encrypt your data during transit between the database service and client applications. Oracle Autonomous Database uses a self-signed certificate stored within the credential file or the wallet for authentication. End users or applications must possess this credential file in order to establish connection with Autonomous Database. This uses MTLS-based authentication for establishing connection with your Autonomous Database. Though it also allows a wallet-less connection, but you can make wallet-based connection to be mandatory during or after provisioning of the database, depending upon the user network access during provisioning. In addition to that, you can use the standard database user management to control their access to the database. You can restrict database access using Microsoft Access Directory. You can control access and permitted operation on the application-sensitive data using database port. You can use a virtual private database and real application security. You can also control access to your Autonomous Database resources by your OCI tenancy users by configuring appropriate IAM privileges for the different user groups. Security risk can be posed even by privileged database users within an Autonomous Database. This can be mitigated using Oracle Database Vault, which comes pre-configured in Autonomous Database. You can create separate realms for customer-sensitive data. You can limit access to those realms protected data to only the right to use privileged users. Attempts to bypass the realms, these are audited. It enforces strong data governance, separation of duties between the administrator and data owners. It also enables you to be in compliance with the regulatory requirement. To wrap up, Oracle Autonomous Database has strong database access control in place that acts as a strong protection shield for your Autonomous Database in Oracle Cloud Infrastructure. We will look into few other capabilities under the self-security feature in the next videos. Thanks for watching. Welcome everyone. In this video, we will discuss about data encryption under self-securing capabilities of an Oracle Autonomous Database. In an Oracle Autonomous Database, encryption is done by default, and you do not have the option to disable it. All your application data, irrespective of its state, that is, data at rest inside your database or in motion when data is being exchanged between the client and your database, in either case, data is always encrypted. Let's check some more details about encryption in each state. Oracle Autonomous Database is configured with Oracle Transparent Data Encryption or TDE. So this ensures all application data being written into your database is encrypted. Data is encrypted at tablespace level with AES 256-bit encryption. The TDE master encryption key is stored in a PKCS 12 key store in the same system as the database. The backups of your database again have their own encryption key different than your tablespace encryption keys. Now let's check the encryption of data in motion. Network encryption is automatically configured by default for data in transit. Client connection with Autonomous Database happens over TCPS or TCP protocol, and all data in transit are encrypted. Depending on the kind of deployment, there are two types of network encryption. If it is an Autonomous Database in shared infrastructure, then it allows only the TCP the TCP/S connection, and these are encrypted using TLS 1.2 security standard. If your deployment is in a dedicated infrastructure or Exadata cloud customer, then it is pre-configured with both types of networking encryption, that is TLS 1.2 or Oracle native network encryption to support the TCP/S and TCP-based connections respectively. Thus, in any kind of deployment, your data in motion is always encrypted. We see autonomous database securely manages your data with complete data encryption, irrespective of whether your data is at rest or in transit, and irrespective of the type of autonomous database deployment. Hope it gave you some basic understanding of data encryption in autonomous database. Thanks for watching. Welcome everyone. In this video, let's discuss how TD master key encryption is handled as part of the self-securing capability in Oracle Autonomous Database. Oracle Autonomous Database uses TD or transparent data encryption to encrypt the data residing in the database. To briefly explain on the functionality of the TD enables encryption of data, and this is a two-tier architecture. As you can see in the image aside, in TD, a master key is generated, and this generates and wraps the tablespace data encryption key. During data access, the master key encrypts or decrypts the tablespace encryption key, and this in turn encrypts and decrypts the data in the data files. By default, Oracle Autonomous Database uses Oracle Managed TD master keys, and these are stored in external security module. The key creates and manages the tablespace encryption keys to protect your data. So it is responsible for encrypting and decrypting the tablespace encryption keys during the access of the data files. Oracle handles rotation of the TD master key in case you are using Oracle Managed encryption keys. Oracle also allows you to use customer managed encryption key for configuring your data encryption. For this, you can configure Autonomous Database to use Oracle Cloud Infrastructure Vault Master encryption key. Using the customer managed master encryption key, Autonomous Database uses it to generate the TD master key, and then the TD master key is then encrypted using this OCI Vault Master encryption key, and this is stored locally on the database. But the customer managed Vault master encryption key is stored in OCI Vault, which is external to your database system. So hence you must ensure not to disable or delete the key, else your database becomes inaccessible. You can rotate the customer managed encryption key, and when you rotate, then it will generate a new TD master key that will be used to again re-encrypt the tablespace encryption key. This happens very fast, and this is an online activity. It does not have to re-encrypt the tablespace data. You can choose between either of the option during provisioning and cloning, or you can change this option post-provisioning using the manage encryption key option under actions menu in the details page of your autonomous database in OCI console. To wrap up, Oracle Autonomous Database gives you the flexibility to choose any of these two different methods for TD master key encryption that will be used for encrypting your data in Oracle Autonomous Database. Hope this adds some clarity, but I advise you to please take a look into the documentation for more details. Thanks for watching. Welcome everyone. In this video, we'll discuss briefly about patching under self-securing capability of an Oracle Autonomous Database. Patching is fully automated in Oracle Autonomous Database. Of the several types of patches, the patches that is a fix for some security vulnerability are immediately applied to protect customer database from any risk. These patches can be for different components of autonomous database. So database, that is firmware, OS, database, clusterware, or the hypervisor. Since autonomous database is hosted in a high availability infrastructure, patch is applied in a rolling fashion in Oracle Autonomous Database. So as to not affect the availability of your autonomous database deployment. Other regular patches are scheduled for applied during the maintenance window. Rescheduling of the maintenance window would be possible in some deployments, but in either case, the maintenance schedule would be visible in OCI console. Of your Oracle Autonomous Database. This was a short video about patching in Autonomous Database. We'll learn more about it as we progress. Thanks for watching. Welcome everyone. In this video, we'll lay some emphasis on auditing feature under self-securing capabilities of an Oracle Autonomous Database. Oracle Autonomous Database default auditing feature helps you keep an eye on the overall database activities. Monitoring these activities can alert you of any untoward so that you can take preventive action at the right time to avoid the situation at that instance, as well as eliminate any future occurrences. By default, there are a few important policies that are already enabled. In those, you can audit any activity by cloud operations on your database, audit all the failed login attempts, which could be a sign of someone trying to break into the database, all password changes, any attempt to create or alter procedures, execution of certain procedures that connect to a network, for example, UTL underscore HTTP, UTL underscore SMTP. You can enable additional policies for addressing compliance requirement, for example, capture audit records for SOX and GDPR, record action on sensitive schemas and tables, investigate suspicious logins. These are some activities you can try to audit. You can add this auditing policies by either using native database auditing configuration steps or use Oracle Dataset Service in Oracle Cloud Infrastructure to enable predefined auditing policies or to enable your customized auditing policies. You can enable fine-grained auditing using the DBMS underscore FG package. The audit records are written to an internal auditable, and normal users cannot perform any DML or DDL on this table. You can view the audit records by querying Unified Audit Trail View. By default, the audit records older than 14 days are purged by the purge job. Audit records can be purged manually by either admin user or any user with audit admin role by invoking the clean audit trail procedure. Oracle Autonomous Database can entirely automate data protection activity by using Oracle Dataset Service in Oracle Cloud Infrastructure. Oracle Autonomous Database Service is natively integrated with Oracle Dataset Service, which is a unified database security control center in Oracle Cloud Infrastructure. Using Oracle Dataset, you can efficiently perform security assessment, user risk assessment, activity auditing, discover sensitive data, and mask them. This gives you a centralized auditing capability. You can send notification alerts for critical risk. You can also schedule regular assessment against a preset baselines to conform to the enterprise-wide compliance standard. Oracle Dataset provides a easy to use management console in OCI. Use management console in OCI to simplify your configuration and a nice intuitive dashboard displaying the summary of all the identified risks. You can use the service for free with Oracle Autonomous Database. Finally, to wrap up on the self-securing capability, it can be assured that Oracle Autonomous Database is a highly secure platform. This is a highly secure platform to keep your database entirely safe in Oracle Cloud Infrastructure. It takes into account almost every vulnerability checks and has added a layer protection to close any scope for exploitation. It encrypts your data in any state. It detects security risk and automatically applies security patches. It has multiple access controls and last but not the least, it has enabled mechanism to monitor database activities and automate its protection. Hope this was helpful to you. Thanks for watching. Say vault service and create your keys for autonomous database that will be used during provisioning. So click on the hamburger menu, identity security, scroll below to vault, and ensure you are in your compartment. Click on create vault. Give a name for your vault. Say we give ADB underscore vault. Click on create vault. So this is in the process of creating your vault. Let's give it a few minutes to complete. So this completes the creation of the vault. Click on ADB vault. So after creation of the vault, we need to add the necessary keys. So here on the left resources part, you find master encryption keys. So click on create key. And here the protection mode, what you're going to choose is HSM. Otherwise, you can choose software. So in this case, we'll choose HSM mode and give it a name, ADB customer managed. And let this be default. It will set to 256 bits by default. And this gives you the option to bring your own keys. When you click on import external key, you'll have to provide the location for your file, and then you can import it. So right now we'll simply create the key, click on create key. So it's in the process of creating the key. So your key has been created. As a next step, we need to create a dynamic group, add a rule to enable autonomous database to access the master encryption key. We also have to define policies for this dynamic group to be able to access this cloud resources. So this has already been pre-configured in my system. I'll just walk you through the different screens. So click on hamburger menu, identity and security, click on dynamic groups. The name of our dynamic group is DG So if you see, I have created a matching rule here, which is resource.compartment ID, and this is the OCI ID of your compartment. Next, we'll see the rules which has been created for this dynamic group. Click on identity and policies, and this is the policy which has been created to allow the dynamic group to access cloud resources. Click on this, and the policies are allow dynamic group name to use vaults, to use keys in this particular compartment. So these are prerequisites which must be completed before you can create autonomous database which can use customer managed encryption key. Now let's move on to create the autonomous database and configure it to use customer managed encryption key. Click on the hamburger menu, Oracle databases, autonomous transaction processing. Click on create autonomous database. Give some display name for this. We'll keep the same name for database. And let's choose the workload type as transaction processing, and deployment type is shared infrastructure. Database version 19C, OCPU count 1, storage 1 TB. Let's disable auto scaling, and then provide the password for administrator. Next, we need to choose network access. Let's keep the default selected, secure access from everywhere. And next, choose the license type. So we'll choose as license included, and you can provide list of email IDs who will be notified for any maintenance activity. Click on show advanced option, and this is the tab where you select how your encryption key should be managed, whether it should be Oracle managed or customer managed. We'll select encrypt using customer managed keys, and then it will prompt you for which particular vault that you can use, and then you'll have to provide the name of the vault in your compartment. So we select as ADB vault, and the corresponding key you can choose from this dropdown. So this is the input which you need to provide when you want the database to be encrypted using customer managed keys. Click on create autonomous database. This will take a few minutes to complete. Let's check it after some time. So our database provisioning has got completed, and the state is now available. You scroll down under encryption, you can see that it is using the customer managed keys which we created in our OCI vault. So this is how you create an autonomous database that will use customer managed keys. There are scenarios where you had created autonomous database that was using Oracle managed keys and you want to change it to customer managed keys, or it was using customer managed keys and you want to change it to Oracle managed keys. So that can be altered by using the manage encryption key option. Click on more actions, and then you click on manage encryption key. So this is where you can change from customer managed keys to Oracle managed keys by clicking on this thing, and vice versa, and then save the changes. This is how you create autonomous database that will be encrypted using Oracle managed keys or customer managed keys. Hope you understood the steps how to first complete the prerequisites before you go ahead with provisioning your autonomous database to use customer managed keys. Thank you. This demo, we are going to see how you can enable IAM user authentication with autonomous database. This is possible with IAM integration into Oracle Autonomous Database. The external authentication is provided by two means. You can either use IAM database password for authentication, or you can use the IAM SSO token for authentication. In case of using IAM database password, clients will try to connect to autonomous database using their IAMDB password, and this external authentication is provided by the IAM integration into autonomous database. There are some configuration steps to be done for allowing an IAM user to connect to autonomous database. First is you have to enable external authentication in your autonomous database. Next, you have to create an IAM user if it doesn't exist and add it to an IAM user group. Then you have to create an IAM database password for that OCI user. Next, you have to create a global user within the database that is mapped to this IAM user group, and you have to grant the necessary DB privilege for allowing the IAM user to connect to the database. So let's begin with the I'm in the OCI console. So let's first create a group. Click on the hamburger menu, identity and security, groups, and let me create a new group. Say IAM underscore DB underscore group, and give the same name for description. Click on create. And right now this group is empty, it doesn't have any member. Let me add myself to this group. So I've been added to this group. The next thing is I have to go back to my profile and create an IAMDB password. Click on your user profile, then user settings, scroll to resources section, click on database password, click on create database password, and provide the description for this. And click on create database password. The password has been created. You can also change the username. Click on edit database username and give it a generic name. And these are changes. This has changed your database username. Now the next step is perform some of the actions on the autonomous database. Click on the hamburger icon, Oracle database, and autonomous transaction processing. So we are in a demo compartment and we have this OUATP database. Click on the database to get into the details page. Click on database actions, and this will open up another tab containing all the tools which are integrated with autonomous database. Click on SQL to open SQL Developer Web. And in the worksheet, let me copy all the statements which we are going to execute now. So these are the set of steps which we'll be executing. The first step is to enable external authentication with OCI IAM. So let's execute this statement. So this is successfully executed. Let's validate the presence of identity provider type. So right now we have OCI IAM. This is what we enabled. Next thing is you have to create a global user within the database that is mapped to the IAM group which you created in OCI console. So this is successfully executed. Let's grant some database privileges for users to log in. So these are the steps we need to execute to enable an IAM user to log in into the database. Now let's go to SQL Developer and try to establish a connection with this IAM user. So the database username what we are going to use is the same name that we changed while configuring IAM database password. And you can find it by clicking on database password, and this is the username. So now let's go to SQL Developer. I've already configured SQL Developer with the connection for OUATP database. Now let's try to establish the connection with ATP dev user. We can provide the username here and the password. Now let's test the connection. So the connection is successful. Now let's connect to the database. Now you are connected to OUATP database with ATP dev user. Now you can perform some normal database operation. For example, I want to create a table. So I can execute this statement. So this table gets created. So this is what I wanted to show, how you can enable an OCI user to authenticate with Autonomous Database using the IAM integration with Oracle Autonomous Database. This completes the demo. Thank you. Hello everyone. Welcome to the learning session on Oracle Database Security in Oracle Cloud Infrastructure. In this lesson, I'll discuss briefly about Oracle Database, how it helps you to automate and secure your Oracle Database and the different environment it supports. Let's begin. Data, as we know, is the most valuable asset, and irrespective of where it resides, it could be in customer data center or in cloud-based deployments like OCI. Unless well protected, it becomes the biggest liability for any organization. Industry analyst report states most of the attacks in an organization are performed by internal players, and more than half of those attacks are targeted at database. So it becomes really imperative to implement higher level of security of your data. Of the different kinds of data that an organization manages, they need to identify and define the criticality of the data that must be well protected from any kind of breaches. They possess several personally identifiable information data like customer date of birth, address or the mobile number, credit card number, SSN, or it may be company-specific confidential information, health card data, finance data, employee data, etc., which are very sensitive in nature. This, if accessed by privileged database user with malicious intent, can be disastrous both for the customer and the organization that was entrusted to keep that information confidential. Keep that information confidential. Hence, it is of hence it is of utmost importance to protect this data. To protect this data not only from external attacks but also from the insider attacks as well. It has also become a globally set standard for organizations that deal with the customer data. They must comply with the different data protection regulation as set by the country in which they are doing business in order to safeguard customer sensitive data. To list a few of the Data Protection Regulations Act, they include European Union's GDPR, or Data Protection Regulation, General Data Protection Regulation, Payment Card Industry Data Security Standards, California Consumer Privacy Act, and many such region-specific regulations. By now, you must have understood that Oracle Cloud Infrastructure provides a secure platform for deploying your databases in OCI. It provides strong encryption of your data at rest or in motion. It applies the different database and system security patches automatically, and also provides a strong separation of duty between the database owner and cloud operator. However, events of data breaches cannot be evaded if there are inherent configuration issues within your database. It can provide open doors to hackers to break into your database and steal sensitive data. Or there could be privileged users within your database who are misusing their access privilege to pull critical information from the database. It would be too late before you detect this debacle, and then you might take a reactive approach to prevent this from further impact. Such experiences might lead you to do some proactive assessment of identifying one such loophole, and it becomes a Herculean task to perform this security assessment when you are incumbent of ensuring complete data security of all the databases you manage. Oracle Dataset is a wonderful database security service that can act as a great rescue under such circumstances.